Just got some breaking news, folks. A 7.2 magnitude earthquake.
And now for a look at stories making headlines around the world, and we start with a powerful earthquake that has struck southern Peru.
Turning to Ecuador now, authorities say at least 2 people are injured in a magnitude 7.2 earthquake that hit the country.
Focus to the other stories that we're tracking. A moderate earthquake jolted Peru's central Pacific coast.
June 16, 2024. A magnitude 4.1 tremor rattles the coast near Arequipa, Peru. Scientists log it and move on. June 19th, another one. Magnitude 4.3. Still, nothing unusual. June 22nd, a third. By June 27th, 5 separate quakes had shaken the exact same fault zone in just 12 days. 5 warnings, 5 chances to connect the dots. And then, at 12:36 a.m. on June 28th, the Nazca Plate tore loose beneath the Pacific, magnitude 7.2. Shallow thrust faulting at 28 kilometers deep. The entire coast convulsed. Highways crumbled. Tsunami sirens screamed across Peru and Chile. 8 people rushed to hospitals, and 600 kilometers away in Lima, families woke to their beds shaking violently. But here's what's keeping seismologists awake at night. Those 5 foreshocks weren't random noise. They were a pattern, a sequence, almost like the fault was testing its grip before it let go. So why didn't anyone see it coming? And more terrifying, what if the M7.2 wasn't the main event? What if the Nazca Plate is just getting started, rewiring the entire subduction zone beneath South America in ways we've never seen before? Stick around, because what scientists found in the 12 days before this quake changes everything we thought we knew about how megathrust faults fail. Let's rewind to June 16th and trace exactly what the ground was trying to tell us. At 2:47 p.m. local time, seismic stations along Peru's southern coast registered a magnitude 4.1 earthquake. Depth, 32 kilometers. Location, 8 kilometers west of Arequipa, directly above the Nazca subduction interface. To the automated systems monitoring thousands of tremors across the Pacific Ring of Fire, this was background noise. Subduction zones shake constantly. Small quakes like this happen dozens of times per month. But 3 days later, on June 19th, a second tremor struck. Magnitude 4.3. Same depth, same location, within a 50-kilometer radius of the first. Then, June 22nd, magnitude 4.5, June 25th, magnitude 4.6, June 27th, magnitude 4.8. 5 earthquakes, each one slightly stronger, each one striking the exact same narrow slice of fault where the Nazca Plate grinds beneath South America. Here's the twist. This wasn't just a cluster, it was an accelerating sequence. Each foreshock releasing more energy than the last, each one pushing the fault closer to failure. Seismologists have a term for this, a foreshock cascade. It's one of the few patterns that consistently appears before major ruptures. Studies from Japan's 2011 Tohoku quake, Chile's 2010 M7.2, and Italy's 2016 Amatrice disaster all documented similar escalations in the days before catastrophic failure. The Peru sequence fit the profile perfectly. Magnitudes climbing in nearly linear progression, spatial, clustering within the fault's locked zone, shallow focal depths indicating stress accumulation in the upper plate interface. Yet no alert system flagged it as dangerous. No seismologist connected the dots in real time. The U.S. Geological Survey monitoring the region logged each tremor, archived the data, and moved on. By the evening of June 27th, after the 5th and strongest foreshock, the fault had finished its countdown. According to Dr. Susan Hauff, a seismologist with the U.S. Geological Survey, foreshock sequences are maddeningly difficult to identify as they're happening. For every cluster that leads to a major quake, there are hundreds that simply fade away. The challenge isn't seeing the pattern after the fact. It's knowing which pattern matters before it's too late. And Dr. Luis Tavera of Peru's Geophysical Institute added, the June 16-27 sequence looked nearly identical to swarms we'd seen in the same region over the past decade that led nowhere. Hindsight gives us clarity. Real-time monitoring gives us noise. But other experts aren't convinced it was just bad luck. Dr. Rachel Abercrombie of Boston University, who specializes in foreshock behavior, put it bluntly. When you have 5 events in 12 days, each progressively stronger, all within a 50-kilometer rupture zone, that's not noise. That's a fault announcing its intentions. The question isn't whether the data was there. It's why our systems aren't designed to recognize it. What made this pattern so remarkable wasn't just the sequence itself. It was how perfectly it matched the textbook model of foreshock escalation. When researchers compared the Peru data against 50 years of global seismic records, they found the June 16-27 sequence ranked in the top 5% of clearest foreshock progressions ever documented. The spatial clustering was nearly perfect. All 5 epicenters fell within a 40-kilometer oval, directly over the patch of fault that would rupture on June 28th. The magnitude progression was almost linear, plotted on a graph, and the trend line points straight toward a M7+ event, and the timing followed a power law acceleration. The intervals between quakes shortened as the sequence progressed. 3 days, 3 days, 3 days, 2 days, 1 day, like a timer counting down. By June 27th, the fault had telegraphed its collapse in a language seismologists claim to speak. And then, at 12:36 a.m. on June 28th, it spoke again. This time, loud enough that the entire world listened. The quake that struck Peru on June 28th wasn't ordinary. A magnitude 7.2 shallow thrust earthquake releases the energy equivalent to 32 Hiroshima bombs. But it's not just the raw power that matters. It's the mechanism. This wasn't a strike-slip quake where plates grind past each other. It wasn't a normal fault where crust collapses under tension. This was megathrust faulting, the most dangerous earthquake type on Earth. Beneath Peru's coast, the Nazca Plate, a massive slab of oceanic crust spanning millions of square kilometers, is diving beneath the South American continent at a rate of 7 centimeters per year. As it descends, friction locks the 2 plates together. Pressure builds, rock bends, stress accumulates for decades or centuries, and then, suddenly, catastrophically, the fault unlocks. When that happens, the overlying continent rebounds upward in seconds, displacing trillions of tons of rock and ocean. The result? Tsunamis, landslides, and earthquakes powerful enough to shift Earth's axis. Peru sits directly above one of the most active segments of the Nazca subduction zone. Since 1950, this region has produced 4 M7.2 plus quakes. The 1970 Ancash earthquake killed 70,000 people. The 2007 Pisco quake devastated central Peru. History shows these aren't isolated events. They're part of a pattern, and the M7.2 on June 28th just added another data point. By early July, researchers began digging into the M7.2 with fresh urgency. Using GPS data and satellite interferometry, they mapped the exact rupture zone. What they found raised alarms. The June 28th quake broke a 60-kilometer section of fault that hadn't ruptured significantly since 1996. Nearly 30 years of accumulated stress released in 45 seconds. But here's what made seismologists nervous. The rupture stopped abruptly at its southern edge, right at the boundary of what geologists call the Nazca Seismic Gap, a 400-kilometer stretch of locked fault between southern Peru and northern Chile that hasn't experienced a major quake in over 140 years. Dr. Bernd Schurer of the GFZ German Research Center for Geosciences described the situation this way. The M7.2 didn't relieve stress, it redistributed it. The energy that didn't release on June 28th is now pushing southward, loading the seismic gap even further. It's like stacking weight on a spring that's already compressed to its limit. Another theory went further. Some researchers whispered about a possible slow slip event, a silent earthquake occurring deep beneath the locked fault zone. These aseismic slips can transfer stress upward, destabilizing shallower sections of the megathrust without producing detectable tremors. If true, the 5 foreshocks weren't random. They were the surface expression of a deeper process. The visible cracks forming as the fault prepared to fail from the bottom up. Less than 600 kilometers north of the June 28th epicenter sits Lima, Peru's capital, home to 11 million people, 1/3 of the entire nation's population concentrated in a single metropolitan area built directly above the Nazca megathrust. USGS hazard models show how even a moderate M7.5 earthquake centered beneath Lima could trigger catastrophic damage. Unreinforced buildings would collapse, landslides would sever highways, the port of Callao, Peru's economic lifeline, could be inoperable for months. But Lima isn't alone. Arequipa, Peru's second-largest city with 1 million residents, sits just 200 kilometers from the seismic gap. Santiago, Chile's capital with 6 million people, straddles the southern end of the Nazca zone. La Paz, Bolivia, perched high in the Andes, remains vulnerable to landslides triggered by distant megathrust quakes. In total, more than 50 million people live within 500 kilometers of the Nazca subduction interface, and most of them have no idea that the ground beneath their feet is one of the most seismically dangerous on Earth. The June 28th quake served as a reminder. Next time, the epicenter might not be offshore, the magnitude might not be 7.2, and the death toll might not be 0. It's not just buildings at risk. The same megathrust that powers the Nazca zone also threatens the infrastructure that keeps South America's west coast functioning. The Pan-American Highway, the primary transportation artery connecting Peru, Chile, Ecuador, and Colombia, runs directly along the coast, hugging the Nazca fault zone for thousands of kilometers. The June 28th quake buried sections of this highway under landslides and rockfalls. Traffic stopped, supply chains fractured. A larger quake could sever the highway completely, isolating entire regions for weeks. Then there's the port system. Peru's economy depends on maritime trade through Callao and Paita. Chile's copper exports, which fuel the global economy, flow through Valparaiso and Antofagasta. All of these ports sit within tsunami flood zones. A megathrust rupture, like the 2010 Chile M7.2, generated waves that damaged harbors as far north as California. A similar event today could paralyze South American shipping for months, sending shockwaves through global supply chains. Today, more than a year after the M7.2, Peru's seismic monitoring network shows normal background activity. The USGS rates the current threat level as green. No unusual tremor swarms, no GPS-detected ground deformation, no anomalous gas emissions. The FORESHOCKS sequence has ended. The aftershocks have faded. Coastal communities have rebuilt damaged roads and returned to normal life. Official reports from Peru's Geophysical Institute state that the June 28th earthquake released accumulated stress along that segment of the Nazca megathrust, reducing the likelihood of another major event in the immediate future. The only unknown is immediate, because seismologists admit they can't define what immediate means for a fault that operates on timescales of decades or centuries. The stress relieved on June 28th might have bought southern Peru another 30 years of quiet, or it might have simply reset a timer that's already ticking again. And the seismic gap to the south, that 400-kilometer locked zone between Peru and Chile, remains unbroken. Still accumulating stress, still waiting. The good news is that South America's earthquake monitoring has improved dramatically over the past decade. Across Peru and Chile, a network of seismic sensors, GPS stations, tide gauges, and satellite systems watches the Nazca zone 24/7. When the next major quake strikes, scientists will detect it within seconds. Tsunami warnings will deploy automatically. Emergency systems will activate faster than ever before. That monitoring network means we'd almost certainly get early warning signs before a megathrust rupture. Days, weeks, or even months of precursory activity, depending on the fault's behavior. But there are limits. Coverage isn't uniform. Some remote coastal areas have sparse sensor networks. Funding constraints mean outdated equipment goes unreplaced. And as the June 28th sequence proved, even perfect data doesn't guarantee recognition. The 5 foreshocks were recorded. The pattern was visible. But no algorithm flagged it. No human analyst connected the dots. So, is a major Nazca megathrust earthquake imminent? Probably not. Right now, every monitoring station along the Peruvian and Chilean coasts reports normal background seismicity. No red flags, no unusual patterns. But the key phrase is right now. The quiet we're experiencing is temporary, and one day it will end. The Nazca subduction zone isn't a relic of the past, it's an active living boundary where two tectonic plates grind together at 7 centimeters per year. That motion doesn't stop, it accumulates. History guarantees that another major earthquake will come. Maybe it's decades away, maybe longer. But the seismic gap south of Peru hasn't ruptured in 140 years. The fault beneath Lima last broke in 1746. The megathrust offshore from Chile produced a M8.8 in 2010 and a M9.5 in 1960, the largest earthquake ever recorded. These aren't isolated events. They're part of a centuries-long cycle of stress buildup and catastrophic release. The M7.2 on June 28, 2024 was a reminder that the Nazca plate is still moving, still pushing, still building toward the next rupture. And when that rupture comes, the foreshocks might give us 12 days of warning, or 12 hours, or 12 seconds. The only certainty is that it's coming. For now, the Nazca megathrust rests, but rest isn't the same as peace. The 5 foreshocks that scientists missed in June 2024 taught us a critical lesson. Even when the Earth speaks clearly, we're still learning to listen. The question isn't whether the Nazca plate will produce another major earthquake. It's whether we'll recognize the warning signs before it's too late. So what do you think? Were the 5 foreshocks just statistical noise that happened to precede a M7.2? Or were they a countdown timer we failed to read? And if the Nazca plate is rewiring how it releases energy, could the entire west coast of South America be on the verge of a seismic awakening that will test every monitoring system, every evacuation plan, and every assumption we've made about megathrust behavior? This is Earth Attacks, where we expose the planet's most destructive forces. Hit subscribe and the notification bell to catch our next deep dive into the earthquakes and tectonic mysteries threatening millions. Because sometimes the ground whispers for 12 days straight, and it pays to listen.